these books in the order of price. How about the price? But the reversing price. So the highest one first comes first. So could you a little bit modify it to sort the books in the reverse order of price, which is the D in the C should be comes first and the Amovable Love comes last. The reverse order of the price. What do you think? Yeah. There might be the many different ways, but I hope you modify or revise this here compare book function, because the reason that we actually define these small functions like a print book, compare book, or swap book, the reason is we want to manage this program as concise as or as readable as possible, right? That means we want to blockwise these programs. So if we actually, definitely you can put this comparable function. You can embed this comparable function within the sort book function. However, in that case, if you want to change some, the comparing metric or some ordering scheme, you need to look at the sorting algorithm as well as a comparison algorithm. However, if you make the comparing function as a separate function, when you want to change the ordering scheme, you only look at this small comparable function. So that's actually huge advantage especially when you build the very large scale program, especially with many other collaborators. So in a large program, the program structure is very complex. So if you do not do such a blockization, then it's very difficult to manage your program. So when you design your any program or software, so the blockwise each function is very important. Okay, so I'm sorry, but because I think we need to record some important lectures in here, and I think there's some lay students. So I will briefly repeat this point as a function argument as one more time. Okay, so let me repeat this one in one more time. Okay, so because you have some lay students, okay, so this is the last one, I hope so. Okay, in the C functions can take pointer variables as argument. Like here, so here integer, for example, in the int function, it can take 4 different variables, int a, float b. These are the regular arguments, regular variable. But here, int asterisk c, this is an integer pointer, and character d and bracket, this is the array. And as I explained in the last section, so the array d itself is equivalent to the pointer. So this is the character pointer. So a and b, the regular variable can be used as a function argument, but also pointer variables can be used. However, importantly, transfer the values are different. If you use the regular a and b variable, actual value of a and b's are transferred to this local function. However, if you use c and d, these are the pointer. So instead of actual values, the address of these variables are transferred to the local functions. So because the actual memory address is transferred, by changing the value of that memory address, we can change the value of that memory address, which means we can change the value of the parent function in the local function by transferring the memory address of the variables. So this one shows the simple example of the function with the integer function with the pointer argument. In the main function, void main, we have two functions: the local function func, func, which has integer variable and integer pointer variable, and we also have the main function main. Okay, two functions. And in the main function, we declare two variables, a and b, and initialize a is 10 and b is 11. So by this declaration, we declare variable in the memory space, variable a in the address 1 and its value is 10, and in variable b in the memory address 2 and its value is 11. So in the main function, we use two memory space for a and b. So if we print out the value and the memory address, 10 gonna be in memory address 1 and 11 gonna be in the memory address 2. That will be printed out by this first printf function. Okay. Then we call this local function func using integer variable a and integer pointer variable and b, right? And we transferred value of a 10 and transferred address of b, which is 2. So by calling this local function is called. Then in this local function, when it starts, two local variables int a and int assert pb is declared. So this local function use the totally separated memory space. So they actually declare variable a in the memory address 100, which is totally separated from main function, and we also declare pointer variable b in the 101. And this 100 memory address 100 initialized by 10 because 10 is transferred, and 101 is initialized to, which is transferred. So the value in a is totally separated one of the a in main function because their memory address is different. So in the local function, if we change a to 20, this a is in the memory as 100. So this value is changed to 20. However, in the parent function, in the main function, the value of a is still remains as 10 because this change is for the memory as 100. However, if we change asterisk pb is equal to 21, asterisk pb means the value in the memory address of pb, and the pb's value is 3. So it changes the value in the memory address of 2 because pb's value is 2. That is here, this one. Actually, b in the main function. So originally it's 11, but it is changed to 21 by this statement. So if we print out this one, 20 gonna be in 100 and 21 gonna be in 2. So after return, okay, if we check a and b again, this a is a here in memory address 1, so it's still 10. So 10 in 1, and the value of b is changed to 21. So 21 in 2. So that means using this pointer variable, we can change the value of the parent functions. Okay. So this one is typically used in this the swap example. And this swap example here is the box, so please change by yourself. Okay. Then we also practice this sorting books. Sort. So if you go over this program, they actually use all so the local functions use all pointer variables, right? So definitely you can. For example, in this print book function, such as the printf function, they do not change the content of b. So definitely you can use the just the variable itself. You can transfer the variable itself. However, you can also transfer the pointer variable. Either is fine. However, so the compare book is also fine because we just read, never write the program, the actual values on the argument. However, when you swap the variables, actual value should be changed. So in this case, we should use pointer variables in order to actually change the order of the elements in the array. Okay, so I believe you already practice this one, so there will be not be difficult to that. Right. So any questions up to this point? Okay, so I believe you already practice a lot for this example. So let me keep a little bit explain more about the pointer and the function arguments. So importantly, pointer arguments of a function can be also used as output variable because we can change the value of that variables. So usually a function returns only one output by return keyword, right? However, for example, okay, so yes, you're right. Yes, that's right. However, but in sometimes we want to get the multiple outputs from the functions. For example, in the scanf case, in this case we use scanf %d and a, right? So in this case, we use the pointer function, but this a can be changed, right? This a can be set it by inputted value by this scanf function. That means this a is sort of output of this scanf, right? So the function output can be given as given by the pointer variable. So let's look at the save log function. So here the program itself is using we got the one floating number using scanf. Then we put the x. Then here call the save log function and use x and error. Okay, so let's think about the log function. So log function is only defined over non-negative, positive. Okay, let's say non-negative numbers. So log of let's say -1, it's not defined, so it's an error. Am I right? So it's like that. So if we just use log, let's say like this, definitely you can understand. Okay, so if x is let's say certain value, let's say the 10, then log of 10, y gonna be the log of 10, certain something 2 point something, right? That is what we expect. But if x is let's say if x is -1, what y should be? So y is float. So y should be number. But that number, y should be number. But what should be that number? So the same situation can be occurred in the a to I. If x is So if the ATOI, so I believe you remember what's the function of the ATOI. ATOI is change string types of a number to the integer type of number. So string 1 to 3 is converted to 123 by ATOI as a number. So this is function. So definitely here, if the 1 to 3 is the input, we can easily expect the n should be 123 because it's the integer. However, if x is something like 1 to 3 a, what n should be? We don't know. Actually, in the real function, in the what is really implemented is n becomes 0. N is 0 in this case. If you put something weird input for the ATOI, n become 0. But the problem is, in this case, if n is 0, there is no way to distinguish between real 0. If we put the real 0 to this function, n will have the real 0. So if it makes error, it also returns 0. But if we put the right 0, it also returns 0. So there's no way to distinguish. So in such a case, we want actually two outputs. One is really converted one. The other is something like black. That actually indicates whether this convert is right or not. So in such a purpose, we can actually use pointers. For example, in this case, we use instead of a log, we design a save log function. Save log function takes two arguments. One is x, which is real value, really converted value, and address of point of errors. Then in the save log function, we test if x is less than 0. If x is less than 0, the error is marked by 1, and we return 0. Otherwise, if x is the right one, x is the non-negative, which means if we can calculate log or define the log, we say asterisk error is 0 and return actual log value of the x. This is the same log. Then once we call this one, we can check if error is 1 or not. If error is 1, this x is something the real value. So we say instead of printing the really converted value, we indicate okay, it's an error by looking at this error because this error's value can be changed by the save log. Otherwise, we can print out value of y. Okay? So this is the simple or typical example to use the two different outputs. But you can actually use many different ways. Okay? Alright, so the point, there's two ways to use as a function argument. One is we comparing the value argument and the pointer argument. So the value argument, for example, we can actually call struct book 1 and struct book 2. Okay? So in this case, in such a way, we can actually use this struct book variable itself as a function argument. In this case, we can read the contents of B1 and B2. However, we cannot change the value of the parent functions, right? Because they use a totally separated memory space. And more importantly, the program becomes slow. It becomes slow. Because usually this struct book, this one has many different fields. many different fields, which means the size of the structured book data is large, right? So simply speaking, so if you look at here, this structured book data type actually has 128 characters and another 128 characters and one integers. So basically the size of this structured book data type is already more than 100 times of the one character, right? So its size is big, very big. So that means whenever we call this function, this large size should be copied from one memory space to the other space. So this the copy, if you want to copy the large size of file, it takes a long time. It's the same. So if you want to copy the large memory, it takes a long time. It's actually very important if you actually want to make a very fast program. You should use you should not use such a way. So if you actually use the structure as a function argument, this type of the function calling is rarely happens. People do not use such a case. Instead, people use a pointer argument. The good thing of the pointer argument is first, we can change the value of the parameters. So by handling B1 and B2 by pointer, we can actually change the content of B1 and content of B2 and also content of R. So instead of returning as a return value, returning value is also the memory copy. So it takes a long time. But in here, by directly writing certain positions, so we can simply use these pointers. So we can instead of returning, we can use by change. We can change the value of the argument, input argument. So good thing is, it is much faster, because by this function, what is transferred are only memory address, not the whole block of the data is not copied. Only memory address is copied. So memory address is a number, just a number. So in this case, just 3 numbers. 1, 2, 3 numbers are copied instead of 3, the total structure of the data. So because we only copied the very small size, it is much faster. So that's why we use pointers instead of value argument. Okay? So that's the very important thing of the use of the pointers. Okay, so here is one more example, but it's a very long example. But please practice this one. If you because this is a very good example in the use of some structures and pointers and something mingled pointers. So please do it in your home. So this is basically the Manito program. So there's the Manito chains. So the Manito chains actually. So here we actually have student structure. So here is my name, and here is Manito's name. I don't know. So you know what's the Manito? You may not know. If you do not know, please watch the drama. 응팔. 네. 네. 마리또가 뭔지 모르면은 찾아보거나 응답하라 1988이라는 드라마를 보세요. 그럼 마리또가 뭔지 알게 됩니다. Okay, this is the Manito program. So Manito program basically, Manito is the hidden secret angel. That means okay, for example, Jane and Seunggi. So Jane is the secret angel of Seunggi. So that means Jane actually prepares certain secret how can I say that? A secret present for Seunggi, but Seunggi never knows. So Jane is the his the secret her secret angel. So in this way, so if you have the 5 students, we have some minor chain. Jane and Seungyi and Hyojin and Minjung and Sonu and Jane. And Jane, okay. So it's actually the circular. However, if you want to the delete or remove the one student, let's say Hyojin. If you want to remove Hyojin, Seungyi should be linked to the Minjung, right? Because we actually removed the Hyojin in this list. So if you remove Hyojin, then we have a new minor chain: Jane, Seungyi, Minjung, Sonu, Jane. So in this way. So this program actually we implement certain minor chain and we can remove anyone we don't like, but it still keep its minor chain. So this is the typical use of the linked list, which you gonna learn in the next year in the data structure and algorithm class. So this is the typical use of the linked list. So if you have time, so please practice this one. Okay, so please practice this one. Any question up to this point? And we have the homework in the due is this Sunday. So in this homework you gonna separate first names into the first name and the last name using some the string parse schemes. So I believe you already know how to parse a string, especially separated by space. Okay, so any question? And I have, and I believe we're gonna have final exam on Monday next week from the 9 to 11:45. So we're gonna have a final exam, right? Okay. So please prepare them. So for that, I didn't copy this one. Just wait. In order to help you to prepare final exam, I upload a certain exercise program exercise for the final. So here we have the midterm programming solutions. So the max, min, max, and the binary to the decimal converter and GCD and LCM. So this is the sample code for the midterm. And I also prepare some programming exercises. That is so some of them is already you solved by as the homework exams. So the matrix multiplication and its a solution and the median of random numbers. I believe you know what's the median. So in order to calculate the median, you need to sort them first, right? Because the definition of the median is something in the middle when you sort them in the order. So that's in here. And also, so this is the save ATOI. This is the save ATOI functions. So the convert the values strings to the integer values. So save number. Then here this is the string sort about the string sort. programs. So some of them you already experienced. Then it's your own strncat, and here the string parse program. And this is this is a little bit error, but but this is about the double sorting. So in the double sorting case, usually so the complex number they do not have a sort. They cannot be sorted, right? Because there's so many ways. So but here we actually using double sort, we can sort the complex number. That means we sort, so if we put the 1 plus 1i and 3 plus 2i, so the real part and imaginary part, we sort real part first, and if they have the same real part, then sort next using imaginary part. So 1 plus 1i, there should be i, but I missed by mistake. I. So these inputted complex numbers are sorted by using the real part first, and if they have the same real part, then they sorted by the imaginary part. So this is double sorting. So this is the example of the double sorting, and this is the Fibonacci series by using some recursive as a recursion of the local functions. So the recursion is a very good technique to implement some algorithms. So please keep in mind the use of the recursion functions. Any question? Okay, so any question? Okay, so basically, actually we have one more session in this Thursday. But this is the average content. So up to now, so for the whole class of this C program language class. So, but we have one more section in Thursday. So I will use that Thursday as a Q&A session. So if you have any question, so please come to the Thursday and freely ask me or TA on Thursday. So I will not check the attendance on the Thursday. So if you have questions, so you can freely come. So if you are very confident on your minor, so you don't have to come just to spend by yourself. Okay, so any question? Okay, so if you have no questions, so it's the very good time for the one semester, and I'm very appreciate your attendance for this class. Okay, so thank you very much. Thank you. 그러면 오늘은 짧게 여기서 잠깐 좀 더 일찍 1시간 정도 일찍 끝내서 말씀하겠습니다. 네, 수고하셨습니다.